Hello, my 7th grade pathway students. So I'm making a separate video for you all because you tend to have a stronger math sense than my honor students, and that's not a knock on them. It's just a natural disposition that you have, which is why you're in the class that you're in. So I'm going to do a review of what we had learned on Thursday. And some of you asked me to do a little bit slower and give you a little more clarification. So I'm going to do that. I'm going to also touch on other rational numbers besides decimals. And then we need to talk briefly about the negatives. After that, I'll set you off to Reveal, to work on the Reveal assignment. I'm actually putting my honor students in Alex because I can carefully select the problems that they do, but I think you guys need to do the challenge problems. I think you guys will benefit from that. So let's get started. First, we're going to go and review what we learned about last Thursday, and that is to take a square root. What we're doing is we are finding the side length of a square, basically. I'm telling you the area. So we're saying, what's the square root of 25? And you're saying, oh, that's 5. And you're giving me the side length, right? So when I said 5 squared, I'm basically saying, okay, I have a square and the side lengths are both 5. And then you're telling me, oh, well, 5 squared is 25. You're giving me the area. 5 by 5. Maybe you didn't even know that's what you were doing. Oops, that's not enough. But that's what you were doing. When you say 5 squared, you're saying that the area is 25. However, when we're taking the square root, we're doing the inverse. We're going the other direction. So you're telling, I'm giving you the area, you're taking the square root, and you're saying that the side length is 5. So far, so good? Okay, what, though, is the solution if I tell you that there are 2 solutions? Well, both 5 times 5 makes 25, but negative 5 times negative 5 also makes 25. Now, you guys are thinkers, so you're probably going to say, well, you can't have negative distance. Like, you can't measure negative. I got it, okay? This is a visual to show you that 2 negatives also equals a positive 25. You are correct. You can't have negative distance, okay? But just for the sake of the visual, can you see that 5 times 5 equals positive 25? And negative 5 times negative 5 also equals positive 25. So if I asked you what number when squared is equal to 25, and you take the square root of both sides, there's actually 2 solutions to this. X is equal to 5, and x is equal to negative 5. So there are different ways we can write that. You can say x is equal to negative 5, comma 5. That's a common way to see it. Another way that this is seen is x is equal to plus minus 5. Now this is, I don't think I introduced that to you last week, but this plus minus symbol represents 2 different values. It is not one number. It means it's a shortcut to write plus 5 and minus 5. It is the 5 family. All 3 of these are acceptable ways of answering this question of the square root of 25. So how do you know when to write what? Well, in my experience, I actually didn't even clarify this in my own mind until I came back to teaching. But if you're asked, oops, that's a 4. If you're asked the square root of 64, well, the answer is simply 8. But if you're asked what all of the different numbers are, the different solutions that result in 64 when squared, what number when squared results in 64? Well, then that answer is going to be negative 8 and positive 8. Or you could say plus minus 8. Again, that's 2 different values in one. So typically you see the principal root and that's what they call the positive root, the principal root, when you're just being asked, what's the square root of this? And you'll see the 2 solutions when you're asked with an x value, like what are all the possible solutions to this equation? Now, it doesn't have to be perfect. What will happen on your assessments is you'll typically see x squared equals 9, and then they'll say, select all that apply. And then they'll try and trick you with 4.5 to see if kids will just divide in half, and they do. Negative 4.5, 3, and negative 3. And obviously you would want to choose both of these because both of those are solutions to that equation. So that's typically how you'll see it. If you just see the square root of, let's say, 16, you simply can answer 4. Okay? Don't sweat it. Again, it's just a little nuanced thing that's important to know, but not the end of the world. All right, let's move on. So then we want to talk about square root of negative numbers. So we said, okay, well, what is the square root of negative 25? Well, remember back to when we had the square a moment ago, and we said, here's the area. What two identical numbers multiply to make negative 25? And we said it can't be done because 5 times 5 is 25, and negative 5 times negative 5 is 25. And then kids will say, oh, well, then it must be negative 5 and positive 25. Well, that doesn't work because these are two very different values. They're 10 apart on a number line. They're not the same number. They may come from the same family, but they are not the same value. And so that does not work. You cannot take the square root of a negative number. There are no two identical factors that when multiplied make a negative 25. They have to be identical and it cannot be done. Okay? So I'll take a quick little mental field trip with you. So what they do is, and again, this is bonus lesson. You can not stress it. Oh, I have to figure out how to lock this screen. It used to come automatically locked, but now I'm having a hard time with it. And I'm having to write without touching it, which is hard to steady my hand. What they do is to take the square root of a negative 25, they've invented what's called an imaginary number system. And again, I just do this with my pathway students. I do not explain this to my honor students, but sometimes you guys tend to like this higher level thinking. So what they decided to do was they said, okay, we're going to make this 25 times negative 1. Okay, they split it out into two different factors. And then they said, okay, well, if I take the square root of 25, then that's 5. And they created an imaginary number system for this. And they said that the square root of negative 1 is I. And it's got a little curl on it so you can really tell that it's an I. And so the answer to that would be 5I. So you're out of the real number system at that point. Now the real number system, if you recall, has natural numbers, whole numbers, integers, rational numbers, and then we're going to get into irrational numbers with pi and the square root of non-perfect squares. But all of these are in the real number system. But now we'll have an imaginary number system. And I'm not going to get, again, too far into that, but that's where that falls. Okay? So, again, if they ask you, oh, what's the square root of negative 36? At this stage, they're going to just say, well, it can't be done. Know that it just cannot be done. Okay? You can't, there's no real square root of negative 36. However, for you guys to understand, that'd be 6I. Okay? Just for fun. All right, so don't worry about that. If that's too much for your brain, forget I said a thing. Just know that you cannot take the square root of a negative number. All right, now moving forward, what about this one, though? What about negative square root of 36? Well, that is negative 1 times the square root of 36. That can be done because that's negative 1 times 6, which is negative 6. So how do I know? Well, again, PEMDAS says, order of operations says, I'm going to take the square root in the exponents before I then multiply times my negative 1. So this is the E of PEMDAS, and this is the M of PEMDAS, which gives me a final answer. Okay? So that's handling negative. So we've talked about the fact that there are two solutions to every square root, and that you can answer with a plus minus symbol to show both numbers at once. We have also addressed negative square roots. And last, I'm going to go back over square root of rational numbers. And I mean by that, fractions, we'll do x and y, and decimals. Okay, that's not a very good way to write that. Let's do like that. Okay, so we need to talk about that part. So when you have a fraction, this is quite easy in that you take the square root of both sides. And when you do that, you get, remember, his job is to cancel squaring. Well, what number here is being squared? And what number here is being squared? Can't be simplified, and there are two answers. So what does that mean? It means that 9/10 when squared is equal to 9/10 times 9/10, which results in 81 over 100, right? That was our original problem. It also means that negative 9/10 when squared also equals positive 81 over 100, because a negative times a negative, you're removing negatives, therefore you're left with positive 81. So both over 100. These are both solutions. You can write it this way, or you can write like this and show both numbers. When you get into Algebra 1 and you start doing quadratics, you're going to have multiple solutions, or at least two solutions almost all the time. So you might want to get into the habit of this, but it's not necessary. This is perfectly acceptable. Okay? So that's fractions. But again, what about decimals? And this is where I think I lost a few people last time because I kind of breezed through it. But here's the deal. When you have a number with a decimal, and it's being multiplied times another factor, identical factor, how many digits will be in the solution? How many decimal places, I should say, will be in the solution? 1, 2. Okay, so this will result into 0.36. So when you take the square root of 0.36, students are going to be tempted to say, oh, that's 0.06. But it's not. And the reason it's not is because if you were to re-multiply that, how many digits would be in the solution? 4. The answer to this is that. So this understanding is based on a solid knowledge. And again, you guys got that in 5th grade because you got some, you were accelerated. You were pushed a little faster. And so that's why I don't really like these programs, because if you're not a super impulsive math doer, it has nothing to do with your intelligence, okay? You guys are very bright, but if you're not quick, then this just leaves you behind. And there's no shame in not being quick and actually having to process it for just a minute. Okay? Some of you guys pick it up lightning quick. That's okay. And some of you don't. And that's also okay. I have twins. I have twin 8th graders. One of them picks up super quick and the other one needs more time. And even a little more time than maybe the average 8th grader. But they're both equal of intelligence. They both get about the same iReady scores. They both score about the same on MCAP. They're both proficient. So, it's like, well, they'll ask me all the time, well, who's smarter? Who's better at math? They're the same. One just processes a little slower. That doesn't make one smarter than the other. They both get A's on their tests. They both get A's in math, except one just was a little bit more impulsive. So he ended up doing the Pathways program, and she ended up just doing 7 Excel. And they're both in Algebra 1 this year. So, being faster doesn't mean better when it comes to math. As a matter of fact, he tends to make more errors and a little bit more of a mess along the way because he's so impulsive. Sometimes he answers before he thinks it through. So we just need to be careful about, the way we look at ourselves and value our math minds. We don't necessarily want to think that faster is better. My point being is that take the time to process this. When you have a number that has 2 decimal places and you're going to multiply it by the exact same number, how many total decimal places will be in the final solution of this? 4, right? You will end up with 4 decimal places in that solution. Okay? So when you take this, let's put that here. So when you take the square root of a number like this, how many decimal places do I want in my original number that I'll square? You only want there to be a total of 2 when it's squared. So before you square it, you only want 1 because this one times this one will make 2 places. That means you want only 1 in your original number that you will square. Okay, I know I've said a lot of things kind of backwards and mismatched, and I'm probably not articulating this very clearly, and I apologize. This is kind of tricky to explain, but if this is the answer and we're starting with the solution, we're starting with the answer, right? It's undoing the answer and going back to the original question, which is what number when squared will result in this? Well, that would be a 1 decimal place number. Will give me 2 in my answer. So if I'm asking you, if I say, okay, this is the question on the test, but really we're undoing this. What was the original number that squared to make me? Well, it would be this because there's 1 decimal place in this, and when I square it, there'll be 2 decimal places in my final solution. So hopefully that makes a little more sense and clarifies that. All right. At this point, you guys are going to swing over to Reveal and go ahead and work in Reveal today. And if you don't finish, please finish it for homework. All right. Bye-bye.